This is similar to the applied problem 2. I've just changed the numbers. So you really can just follow along with me. Just use your numbers instead of my numbers that I'm using in the video. Okay. So how many customers will the company have? They increase the price by $10. So it says that we're going to lose 4 customers if we increase the price by $5. So if we double that, then we're doubling this number. You should be losing 8 customers. So right now I'm set at 30. But I'm losing 8 customers because I'm increasing the price in 2 increments of $5. I should have 22 customers. So nothing tricky there, nothing tricky in the first 2 steps. Because the second one says how many customers will the company have? They decrease the price by $10. So going in reverse. Okay, and it's not explicitly said, but let's assume that we're going to be increasing customers if we decrease the price. Because if it's cheaper, more people are going to be willing to buy it. So if you decrease it by $5, you get another customer. Another 4 customers, I should say. So that put us at 34. If we decrease it by $5 again, that puts us at 38. It'll be 38 customers if we decrease the price by $10. And now here's where we start doing some algebra. We're going to let x be the number of times we increase the price by $5. So what's the price of the product when x equals 3? So the price right now for my product is $200, but we're going to add 3x to it. We're going to add 5x because x represents the number of times the company increases the price by $5. So when x equals 1, we've increased the price by $5. When x equals 2, like in this example, we do 5 times 2 makes 10. We increase it by $10. That's the expression we really want. And you've got 200 plus 5 times 3, increasing the price by 3 increments of $5. We should have $215. And that's the expression they want for part 4. If you've already written that, you've got it. This represents the price of the product. Okay? It starts at $200, and for every 1 increase in x, we've gone up by another $5 in price, because x represents the number of times we boost the price by $5. Now, part 5, though, isn't about money. It's about the number of customers we have. Okay, so we start with 30 customers, but we're losing customers. We're losing 4 customers every time x increases by 1. So you need a variable there, just like we did in part 2. Because if x equals 2, you've gone down to... So if x equals -2, which means you've decreased the price, then you've gone up to 38 people, because -2 times -4 makes +8. That's the expression that represents how many people we have, depending on the number of times we change the price. Okay, and those are here because we're putting it all together in part 6. We're trying to find out the best price so we can maximize our revenue. And revenue is the price of a product, which is a variable, right? It's a price that can fluctuate. We said we can increase by $5 or decrease by $5. So that's a variable. And then we're going to multiply that times the number of customers. That's why we need to put it in parentheses, so that we multiply this whole thing times the number of customers. So that's the revenue function. And the last part, since we haven't really studied quadratics in this course, the maximum is going to be the vertex. But if you've had quadratics, you know what that means. But you don't have to... You don't have to know quadratics yet, because we're getting to that soon in the class. This last part just asks you to take that revenue and try out some numbers. So plug in x equals 1. See what the revenue is. And so if you plug in 1 in here and simplify with pen and paper, you get 200 plus 5 makes 205. And then that's 205 times 26. That makes $5,330. And try out x equals -1. See what happens. And so if you plug in -1, then the price goes down to $195, and then you've got 34 customers. So just decreasing the price by $5 made us, if I did that right, made us increase by over $1,000. Let me just double check. 195 times, and then 205 times. Okay, so that tells me if I'm looking for the best revenue, I probably want to go in the negatives. Let's try x equals -2. So that's going to give us 190 for a price. It's going to give us 38 customers. We're still going up. So how many numbers does it say? Oh, sorry, I forgot where we are in terms of the course. It says it is quadratic. So this must be the same unit where we're doing quadratics. I'm making this during the summer session, and it's a 5.5 week course, so I'm not sure what people intend by the time they get to this. So this is quadratic. So look, this is getting us towards the right answer. We know it's going to be somewhere in the negatives because that's making our revenue go up. But to find out the maximum or minimum of a quadratic, you need to know the vertex. And you can find that by distributing this and putting it in standard form. So 200 times 30 makes 6,000. So 200 times negative 4x makes negative 800x. 5x times 30 makes 150x. And then 5x times negative 4x makes negative 20x squared. Ran out of room there. So in descending powers, it's negative 20x squared minus 650x plus 6,000. Okay, so that's the quadratic equation. The vertex happens when x equals negative b divided by 2a. This is, oh, I forgot my x here. This is your b, the coefficient of the x to the first power. So I've got a negative 650. That means I'm going to put in positive 650 up top. And divide that by 2 times a, so negative 40 in the denominator here. And then if you simplify that, divide by negative 40, that's negative 16.25, because it's divided by a negative. Okay, so now I can answer the question, what price should it be? Well, this tells us the price, right? And we just found out the maximum happens when x equals negative 16.25. So our maximum price is this result. I'll leave it there because mine is just made up numbers. But you want to plug in negative 16.25 in for x. And when you simplify, that's the price that's going to get you the maximum revenue.